Well, good morning, my Algebra students. Here we go with Study Guide Chapter 7 Solutions. All right, so number 1 talks about prime factorization, and we know that we want to factor this just to prime numbers. So however you choose to do this, I decided to go 10 times 10 is 100, and then I broke down 10 as 2 5s and 2 2s, right? So 2 to the second times 5 to the second is our prime factorization. And number 2, we have to do the GCF of 18b to the fourth and 27b to the second, which means that we have 9b to the second is going to be our GCF, and that's all it asks us to do. It does not ask us to factor. It just says what is the GCF. Make sure we're really answering what is the question and not just throwing in extra stuff. Okay, number 3, we have to match which one's the prime factorization. I went ahead and factored this out to make sure I did it right. So I see that there's 2 2s, a 3, and a 5. So A is the correct answer. B is not right because 4 is not factored, and C is not right because 15 is not factored, and D is not right because 2 is not squared. On number 4, it asks us for the GCF of 10 and 15, which is 5. And then x and x squared will be x. So obviously the answer is 5x. All right, which brings us on to now 7.2 of how to factor. Now it says to factor by using the GCF. So we're going to factor out between 15 and 20 is 5, and x to the third is the largest amount of x's we can divide off, giving us 3x squared minus 4. I have to have this whole answer to be the right thing. On number 6, my GCF is going to be 4p squared. Now, I could have taken out negative 4p squared as well, and I would have gotten this, right? And that was first part of 7.2. The second part was factoring by grouping. And we factor by grouping because there is not a GCF until we group, and then we take out a GCF out of each group. Finding out there's a hidden GCF that we can then factor out, right? So number 8, we're going to go ahead and factor out a GCF. We take out n from the first, and then negative 3 from the second, finding our hidden GCF of n squared minus 5. All right, number 9, it's 7.3, factoring using Xbox. You know, and if you have not mastered how to do Xbox, you need to watch the 7.3 video, because some of you are not factoring it the same way, and it unless you're doing the different kind of Xbox, which I have just a couple students that do that. That's fine. You know who you are. Excellent. But if you're factoring it by listing out the factors, it is time for you to go back, watch 7.3, and factor using Xbox, right? So on the first one, we see it's a perfect trinomial, but we also know that 2 numbers that multiply to be 25 and add to be 10 will be 5 and 5. Once I find these 2 factors, I'm done. I just have to write x plus 5 and x plus 5. Then number 10, 2 numbers that multiply to be 12 and add to be negative 8 are going to be negative 6 and negative 2, because a negative times a negative is a positive, and a negative plus a negative is a negative, right? Notice I did not need to factor by grouping. I did not need to put anything else down. I'm done at this point. Okay, 11 and 12, we're just going to take a little moment to look at a difference of 2 squares. On here, we know it's a difference of 2 squares because one is difference, which is subtraction, and each side is a perfect square. So to square root an exponent, I just divide by 2, and a whole number, I square root it. Put it in my calculator, right? So I get x plus 11 and x minus 11. On number 12, I have to square root 100, and I can square root x to the fourth, and I can square root 81. So I know it's a difference of 2 squares. So it'll be 10x squared plus a minus 9, right? All right, on number 13, we are in 7-4, which is AC X box. So we multiply the A and the C, which is 24, to add to be 10. And again, I find my two factors, and now two numbers that multiply to be 24, 6 and 4, and add to be 10x would be 6x and 4x. And I have to factor by grouping. I put the 3x and the 8 down. And then what adds up to be 10x goes in the middle. And it doesn't matter, I could put the 4x first and the 6x second, or whatever you want to do. It won't matter, you will get to the same thing. And then I factor by grouping, right? This is 7-2 meeting 7-3 to become 7-4. And then I take a GCF out to find a hidden GCF, and I regroup. Now, back in the day, before we had this, we used to just guess and check and guess and check. And some of you are doing that. Actually, I can only think of one of you are doing that now. So please embrace AC method. It'll make your life a lot easier when you do more complicated things in Algebra 2. All right. Let's look at 14, doing my AC method. Two numbers that multiply to be 36 and add to be 15 will be 12 and 3. And then I factor by grouping. I bring down the 4x squared, I bring down the 9, and I put my two middle terms. Again, I could switch it. I could have put 3x first and 12 second, but I know 3 goes with 9 well to factor, and 12 goes with 4 well to factor to find a greatest common factor. So I do want to just take a little minute and look up before I put down my fractions. I put down my factors so that I can factor easier, right? And I take out that hidden GCF of x plus 3. Okay, now we are factoring completely, right? So in order to do this, we follow our patterns. We always take out a GCF first if we can, right? So number 15, I take out a 3, which reveals to me a difference of 2 squares inside. Right? 16, I take out a GCF, and I see that it has an X box inside. 17, I take out a GCF, and I see that there is a difference of 2 squares. 18, it looks like it's going to be grouping, but first I'm going to take out a GCF. If I don't do this, I might miss something later. Now I take out a greatest common factor to reveal that hidden GCF of 5m plus 2. And when I regroup, I see, I have a hidden difference of 2 squares. If I didn't take out the 2, then this blue factor would have been 2m squared minus 18, and I might miss that that's a difference of 2 squares. But I could have taken out GCF then too. But either way, I know that it is m plus 3, m minus 3 is my final answer, times 5m plus 2 times 2. Last two questions are kind of word problems. Got to use our words to explain these. Determine whether this is a difference of 2 squares, and if so, if not, then choose the correct factorization. So on here, I can say no because 10 is not a perfect square. It's a decimal, right? So that means I have to take out a GCF. Is going to be my correct factoring method. And I take out a 2, and I get 2x squared minus 5. And that's factored completely, so I'm done. On number 20, last question, I can do this a lot of different ways. It's just saying, hey, is this the factoring of this problem? And I could look at this and say, well, if I multiply it back out like I did in chapter 6, I see that, yes, I get back to where I was. And that middle term is 2x and it ends with negative 24. Or I could have x-boxed it and just said, wait, two numbers that multiply to be negative 24 and add to be positive 2, it couldn't be like this, so I'd have to make sure that it was a positive 6 and a negative 4, and that would make positive 2. So that would be right. Okay, guys, we're going to be doing this project today and tomorrow. Make sure you get it done. if you don't finish it in class. And then on our test day, which will be Thursday and Friday, depending if you're an A day or a B day. A is Thursday and B is Friday. Make sure that you have your binder check ready to turn in. You're not doing it in class. You're going to turn it in, take the test, and then away we go. All right? Have a great day.